Great. This video is identifying quadrilaterals using distance formula and slope. So what we're going to do is go through we're going to do 6 quadrilaterals. And what we're going to talk about is the characteristics of those quadrilaterals. And then I'm going to show you how we'll use distance formula and slope to determine which quadrilateral we're talking about. All right, so I'm going to start with a chart. So I am going to draw down the side, and I have no idea. I might end up extending this a little bit. But I think it should be helpful if we go through, wow, that was really straight. Okay, if we go through each quadrilateral and then what the characteristics are of the sides and then what the characteristics are for the slopes. Okay, so I am going to start by just doing, oh my gosh, I'm having like a really good line day here. Okay, so this is going to be the name of the quadrilateral right here. And then we're going to look at the information about the side lengths and then the information about the angles or the slopes. So I'm going to put angle, slopes, and then I'm going to put sides and distance. All right. So here's what's happening. Like we know, for example, that a square has 4 right angles and 4 sides that are the same length. Okay, so if we wanted to prove something was a square, we would have to show that the 4 sides are all the same length. So that means we would need to do the distance formula for the 4 sides of the square to show that the 4 sides are the same length. And then we also know that in a square, the angles are 90-degree angles. So what we would need to do is find the slope of each side of the square and show that the slopes were perpendicular. So that's how we are attacking this whole situation. So I think that we need to go through the different quadrilaterals first so that you know what you need to know about each one. All right, so first up, we're just going to talk about the basic quadrilateral, okay? So the basic oh my gosh, sorry. The basic, okay, I made a mess. Quadrilateral, all right. And this marker isn't helping either. Okay, that's supposed to be UAD. Okay, so a quadrilateral, all that means is that we have 4 sides. So it could be like, something like that. All right. So quadrilateral just has 4 sides. That's all there is to it. So we would know a quadrilateral because they don't have to have any common side lengths. Okay. So we don't have to have any equal sides. And there is nothing parallel or perpendicular about a quadrilateral, so we can have unlike slopes. All right, so that's just a plain old kind of boring, hate to say, boring quadrilateral. All right. So next up, let's talk about a parallelogram. Okay, so a parallelogram, so I better concentrate. Parallelogram, oh my gosh, almost didn't fit it. All right, so the deal with a parallelogram is we usually think of a parallelogram as looking like something like that. All right, so the deal is that opposite sides are parallel and the same length. So that means that this side up here has to be the same length as that side. And then this side on the left has to be the same length as on the right. So we have two equal sides. And actually we have two pairs of two equal sides. All right. So maybe I'll even say two pairs of two equal sides. Okay. Now, the slopes can be different, but at the same time, we know that the slope of this side is going to be the same as the slope of that side in order for them to be parallel. And then the slope of the top is going to be the same as the slope of the bottom because those sides are going to be parallel. And in order to have parallel sides, slopes are the same. So we are going to have two pairs of equal slope. All right. And I'm thinking I should probably draw a line to separate these in here. So let me get this in there. I guess it's just, yeah, I don't know, having a good day here with drawing the lines. So you know I'm going to have a really bad one in a second, but okay. All right. Next shape, let's go with a rectangle because that one kind of comes next in the family lineup. All right, so talking about a rectangle. All right, so first of all, we usually think of a rectangle like this, okay? So let's talk about what we know about a rectangle. Well, we know that the top and the bottom are the same length, and the left side and the right side are the same length. So just like the parallelogram, we're going to have two pairs of equal sides. All right, so I think I'm going to write that a little bit better this time. So two pairs of equal sides. And I really probably should be using the word congruent instead of equal. Okay, the other thing that happens with a rectangle is the top is parallel to the bottom and the left side is parallel to the right side. But not only that, is the top and bottom are perpendicular to the right and left sides. So we need two pairs of equal slopes that are also perpendicular. Okay, so we have two pairs of, and I'm going to change over to congruent. Let's go with two pairs of equal slopes that are also, and perpendicular. All right, that's a lot. So if we're going to prove that something is a rectangle, we have to show that the top and the bottom are the same length, the left side and the right side are the same length, but they're different from each other. And then we have to show that the top and the bottom are parallel, the left and the right are parallel, but then those parallel sides have to be perpendicular. Woo! All right. So now, after a rectangle, let's go to a rhombus. All right. So, a rhombus, what happens with a rhombus is we usually think of them kind of like a diamond maybe. So I don't know if I'm going to do a good job. Well, that's okay, I guess. All right. Another way people will see a rhombus is kind of like a parallelogram, except the deal with a rhombus is that all four sides are the same. Okay? So we have to have 4 congruent sides. So if the 4 sides are not the same, we know it's not a rhombus. So the 4 sides have to be the same. All right, and then we still need the top to be parallel to the bottom, and we still need the left to be parallel to the right. So we need 2 equal, or 2 pairs with the same slope, but they're not perpendicular. All right, so we need 2 pairs of same slope, but not perpendicular. Okay, so we don't want them to make right angles on a rhombus. So we know that those 2 angles are going to be the same, and then these are going to be the same as that, and the sides are parallel, but they're not right angles. Okay? All right, so next up, let's do square. So I'm going to get to this one. All right, I'm still having an amazing straight line day. This is like incredible. This is like history making. All right, so square is the perfect quadrilateral. So the square is the regular quadrilateral. So the deal with the square is that it has all of the characteristics of above. So all 4 sides are congruent. So we would need to have 4 congruent sides. We know that the top is going to be parallel to the bottom and the right is going to be parallel to the left, but they're also going to be perpendicular. So it's the same as the rectangle. So we need 2 pairs of same slope, and again, they need to be perpendicular on a square. All right, so the difference between a square and a rectangle is that the square, all 4 sides are the same, and on a rectangle, there's only 2 equal sides. So the opposite sides are equal, not all sides are equal. All right, and then the last one that I want to talk about is a trapezoid, and then I will show you how we figure this out. Like seriously, like I am impressing myself here. Okay, so what did I say? Trapezoid, all right. So we don't need a huge line for that. All right, let's see if I can, wow. Like this is amazing. I need to like keep this forever. Okay. So our last one, let's do, oops, I forgot to do the lines down. Hold on. This is where I'm going to mess it up because I'm not going to be able to make those straight, but oh well. Okay. All right. Last one is a trapezoid. Now, there's lots of trapezoids. So the bottom line, though, is that because there is an isosceles trapezoid, and that's the one that looks like this, okay? Where these 2 legs are the same length, but they don't have to be. We could have a trapezoid that looks like this. So the deal with a trapezoid is that there's only 1 pair of parallel sides. So we can have no equal sides, or we can have equal sides. It doesn't matter, okay? But on the slope, we only have only 1 pair are parallel slopes. Maybe I should have left more space. So we have only 1 pair of parallel sides on a trapezoid. So this side right here is parallel to this one, and this side is parallel to that one, but the other sides are not parallel. And it doesn't matter if they're perpendicular because there's only 1 set of parallel sides. All right. Okay, so now let me show you an example here. All right, so let's say that I gave you, we'll just go with A, B, C, D. Okay, so A is 1, 7, B is -3, -3. C is 2, -5. And D is 6, 5. Okay. So we're not graphing this. We're going to do all of this just by looking knowledge of distance and slope. Okay, so first thing is I need to figure out the length of all my sides. So I need side AB, side BC, side CD, and then side AD. Okay, so using the distance formula, okay, so I'm going to cover these two up because I don't need these. So side AB, this side is 4 squared. This side is 10 squared. So that's 16 plus 100. So this is 116. Now, I don't really need to go any further than that because all I'm trying to do is see if they're the same or not. All right, so now I'm going to try side BC. So the distance between those two sides is 5. The distance between those two sides is 2. So this is 25 and 4. So this side is root 29. All right, so now I'm going to find the length of CD. So the distance between those two is 4. The distance between those two is 10. So that gives me 116. All right, so now I know that those two are opposite sides, so that's good. And then A and D. So the distance between those two sides, or those two corners, sorry, is 5, and there is 2, and that gives me the square root of 29. So what I know is that AB is the same length as CD. So AB is congruent to CD, and I know that BC is congruent to AD. So if I just think of this shape, okay, so I'm just going to say ABCD is right here like this. Okay, so I am just sketching this out. All right, I know that this side is congruent to that side, and I know that BC is congruent to AD. All right, so far I know that this is not a square because the 4 sides are not equal, and I also know it's not a rhombus because the 4 sides are not equal. So I'm kind of zeroing in on maybe it's a parallelogram or a rectangle. Okay? All right, so now what we need to do is look at the slopes of the 4 sides. So the slopes of the 4 sides are going to show me whether these sides are parallel with each other or perpendicular with each other or like some of both. All right, so first up, the slope of this one, okay? So the slope of side AB. So y minus y would be 10, and x minus x would be 4. So the slope of that side is 5 over 2. Now, if you notice, they're the same numbers that we're using right in here. All right? So for the slope of BC, so y minus y would be 2, and x minus x is 5. So the slope of line BC is 2/5. All right. Oh wait, sorry, that's a negative right there. All right, so y minus y is positive 2, x minus x would be negative 5. All right, so now I'm doing the slope of CD. I'm kind of running out of space, so maybe I'll go over here. The slope of CD, so looking at C and D. So y minus y would be negative 10. X minus x would be negative 4, but that reduces to 5 over 2. So I know that these two sides are parallel because they both have the same slope. All right, so now let's find the slope of side AD. So y minus y is 2, and x minus x is negative 5. So now I know that those two are parallel. So I know that this side is parallel to this side, and this side is parallel to this side. Okay, but the question is, I have two pairs of parallel sides, but are they also perpendicular? Because if they're perpendicular, then I have a rectangle. If they're not perpendicular, then I have a parallelogram. So when I look at these slopes here, it's the opposite sign reciprocal, which tells me that these sides are perpendicular. So I have right angles on all of these. So now I know that this shape is a rectangle. Whew, a lot of work there, huh? All right, so that's just showing you how the distance formula can be used to prove or disprove a quadrilateral. It can also be done for other shapes. We're just focusing on quadrilaterals. But we can tell whether a shape is going to be just a quadrilateral, parallelogram, rectangle, rhombus, square, or trapezoid by finding the lengths of the sides and then finding the slopes to see if the sides are parallel or perpendicular or not. All right, so a lot of information there, but that's identifying quadrilaterals using distance formula and slope.